Dr. Ron Eglash is a professor of the School of Information at the University of Michigan. His work as a Fulbright scholar was published as African Fractals, Modern Computing, and Indigenous Design. Audrey Bennett is an inaugural university diversity and social transformation professor in the Integrative Design program at the University of Michigan. She's done fascinating work on the African roots of Swiss design. Please welcome Audrey and Ron.
We would like to preface our presentation with an acknowledgement of the University of Michigan's origins and a land grant from the Anishinaabe and Wyandot. We further acknowledge that we're sitting here on lands obtained generally in unconscionable ways from Indigenous peoples. Our creative practices and research in art and design here in Ann Arbor, Michigan have benefited and continues to benefit from access to land originally gained through the exploitation of others. Knowing where we live and work does not change the past, but a thorough understanding of the ongoing consequences of this past can empower us in our educational and professional endeavors to create a future that supports human flourishing and justice for all individuals. Thank you so much for this opportunity. We are honored to be presenting our research at the National AIGA conference today. I am a graphic design scholar and professor of art and design at the Penny W. Stamp School of Art and Design at the University of Michigan.
And I'm a professor in the School of Information, also at the University of Michigan.
We begin with a look at the 19th century racist models for biology. These assume that life was arranged as a ladder. It was a great chain of being, from primitive organisms to primitive humans to white people. Biologists now know that is not how nature works. Success in evolution is not perfection, it is diversification. For example, once birds developed physiological principles for flight, everything from condors to hummingbirds became possible. As human designers, we too need to create design trajectories, principles for navigating the space of possibilities that embed diversity, justice, and sustainability into practices and design outcomes. Our research is focused on developing generative design trajectories inspired by and in conversation with Indigenous cultures.
We corrected for biology, but we foolishly maintain the same ladder model for differences in cultural knowledge. Indigenous knowledge is not primitive, but it does reflect a radically different way of being in the world. When we look at those branching forms of knowledge, we can see that Europe's knowledge branch took its trajectory by focusing on the extraction of value. Economists said business must optimize by de-skilling. Machines to replace human skill created engineering, and engineering proved the value of optimization. Extraction just leading to more extraction. But nature's economy is not based on this death spiral of value extraction. It's the life cycle of generativity. Living systems are nonlinear, adaptive, self-modifying. They organize from the bottom up, not the top down. And indigenous traditions base their science and technology on these bottom-up generative phenomena. Now, when I first saw fractals in African architecture, I too thought they were unintentional. Coral reefs are fractal, termite mounds are fractal, so I just assumed that some kind of bottom-up unintentional dynamic was at work creating these social forms. It was not until I began my fieldwork in Africa that I found local folks had algorithms for generating these fractal structures. Granted, they're not algorithms written in machine language. They're encoded in cosmologies, ecological relationships, and other mixtures of material and symbolic practices. But they're just as sophisticated and complex as any computer algorithm, if not more so. Now here you see the scaling circles at the level of a village. Within that, scaling circles of a single homestead. Within that, this scaling stack containers. In Burkina Faso, when the woman who runs this household dies, they break that stack in a ceremony, and her soul goes off to eternity. When a new child is born, the soul comes back. And so in the first iteration, the first cycle of that recursion, the baby is in the same room. In the next iteration of your life cycle, you're a toddler, so you're out in the courtyard. In the next iteration, an adolescent, you're out in the village as a whole. As an adult, you're in the world as a whole. So it's a fractal structure encompassing the entire earth, but it's also infinity in the palm of your hand. In other words, recursive scaling is a conscious design theme in most African cultures. We have trouble recognizing these evolutionary trajectories because we've been blind to knowledge based on generative systems. And it's not just symbolic. The reason for visualizing recursion is that these circular flows are fundamental to these indigenous economies. For example, here's my friend Gabriel Boache in the upper left photo. Unfortunately, he just passed away a couple of years ago. He's getting bark from the body tree to make ink for these adinkra stamps. And once that pigment is removed from the bark, the remainder is then composted. In some cases, that compost is put into a sacred forest. Monkeys and birds eat those plants and spread those seeds to other areas, which include the body trees. So the whole thing is just this beautiful circular economy. Not so for Europe. Europeans optimized the single plant variety that would bring them the greatest profit. Over and over again, you see them focusing on money in search of more money, optimization for one single variety, monoculture from monotheism. Native Americans, in contrast, generated biodiversity. The trickster gods, coyote, raven, and others, embody the unpredictability of nature. It's a flood one year, there's a drought the next, then comes bugs or a fungus. The only way to keep up against the diverse tricks of nature is to have an equally diverse set of genetic resources. And that's why Europeans were astounded to find this explosion of biodiversity in the New World. Plants they had never seen, corn, potatoes, tomatoes. I don't know what the Italians were putting on spaghetti and pizza before the New World, but it wasn't tomatoes. That's a New World plant. Peanuts, New World plant. Vanilla, chocolate, cinchona bark, which is used against malaria. You can imagine how this facilitated all these voyages into the tropics, right? Even rubber, for crying out loud, was a South American plant innovation from the native people. So the impact from these Native American bio-innovations is just as astounding as it is unrecognized. So now we can understand why it is so hard to see indigenous STEM, even when it's staring you right in the face. Western STEM was created for the purpose of optimizing value extraction. We're trained to see that as the only version of knowledge. Indigenous STEM, in contrast, is focused on preventing value extraction. Now imagine after work, you go to your parking lot, to your car, and you see your boss pack 10,000 ears of corn into his car, and you only have 100. But that's never going to happen because money, the banking technology, it's all there to make this labor value theft invisible. Indigenous designs work in just the opposite way. The reason you see hundreds of tiny little beads and stitches and carving strokes and braids and so on, that's to help visualize the labor value that went into it so that everybody can see it, so that it's transparent and above board. Somebody might say, well, I put micro braids into her cornrows and it took me 4 hours, but you can see the love.
For the past 20 plus years, Ron and I have been applying these heritage algorithms to the design of STEM education. But if we are merely diversifying the input to the STEM pipeline and allowing the output to be the same old labor exploitation, pollution, and militarized AI, we have failed. Instead, we need generative STEM education that can transform our techno-economy from extractive to circular flows. Our research has led to the development of a suite of software applications called CSDTs, which stands for Culturally Situated Design Tools. Here you can see that visitors to the site have a variety of cultures and knowledge sources to explore. We have a CSDT DT for cornrow braiding, bead looming, yarn art, sci-fi, adinkra stamping, henna, and most recently, quilting. Each CSDT's design process begins with our ensuring that we have cultural permission, that the custodians of the Indigenous practice want to collaborate in making their knowledge available for STEM education. We then do interviews to make sure we're presenting to heritage algorithms as they see it and not imposing our own ideas. The children learn coding and math through the cultural tradition, but that is only the start. Once understood, we see an explosion of creativity in their designs, often bringing in other cultural elements in a lively sense of hybridity.
The application of STEM education is only the first part of the cycle. We then bring those results back to the adult artisans. In this case, students 3D printed their cornrow simulations as mannequin heads, which the braiders then displayed in their shop. And then the braiders suggested research on chemical analysis of hair products. And out of that effort, one of them launched her own line of pH-neutral organic alternatives.
In 2003, I published a paper, a journal article, on using these heritage algorithms to define the Black aesthetic in graphic design. My recent update of that focused on the African roots of the Fibonacci sequence. Our partners in Ghana brought back this older pattern with a new set of colors in digital marketing. You can even purchase your own at AfroFuturist.org. In turn, they've conducted STEM education outreach using CSDT simulations, a great example of this generative cycle that we've been speaking about.
Each time the generative cycle completes a loop, new opportunities for less exploitative forms of labor, production, and consumption emerge. For example, with our Ghanaian collaborators, we recently developed a machine learning app to prevent tourists from accidentally buying factory-made fakes instead of authentic weavings. We hope to extend that to a link that will allow the weavers to show up in your home or classroom and have a conversation with you. So it's really changing the consumption patterns as well as the production patterns. This is another example in Detroit. We've been collaborating with the African Bead Museum on an Afrofuturist greenhouse where we'll be growing dye plants, seed plants for necklaces and other products. It'll all be watered by rain catchment, powered by solar photovoltaics, and all cyborged together with digital sensors and AI monitoring. Some of these generative technologies have even broader circulations. In the upper left, you see a building in Ethiopia that was inspired by the African Fractals book. The fractal perforations allow the building to breathe, and that eliminated the need for air conditioning and thus made rental space affordable for local merchants, as well as reducing the carbon footprint. At the center, you see how Annette Okafor featured our computational braiding in her new children's sci-fi. We then added a new simulation to our tools based on her sci-fi and added passages from a book to our STEM teaching materials. So it's really completing these cycles several times over. To summarize, human society the world over was once using the kinds of generative loops that we see in nature. And these cycles have been broken by extractive traditions. We see the role of design as a kind of prosthetic for a wounded society. We call for restorative technologies that allow ecological value, labor value, and social value to flow back to those who created it, for new webs of transformation towards generative justice.
Thank you very much.
Thank you so much, Audrey and Ron. So I guess my first question is, how do you build in the guardrails so that as you explore, and expose more people to generative systems, that they don't become extractive, that they don't get subvertive and commodified and all these things that have happened in the past?
So we recently got a new National Science Foundation grant to start working with a broader set of community actors in Detroit. And a great example would be one of the textile artisans wanted to import some cloth from Ghana. So we connected her with our weavers. We have another group in Ghana that's been using laser cutters with the simulations, the AfricanFuturist.org group. But we needed some way to handle shipping. Mm-hmm. And so a colleague of mine in a group called Poverty Solutions at University of Michigan, really wonderful group, knew somebody who had started a sort of a community-based e-fulfillment service. So not Amazon, right, which is this huge extractive monster, but just, mom and pop style e-service. So that was just a natural connection. So that's I think the best way to build in those guardrails is, don't get involved in the first place in any point of extraction, right? Try to keep everything community-based.
In recognizing these sort of generative design and these fractals and stuff, it strikes me that there's a cognitive bias for why you don't necessarily see them, because they mimic nature, and maybe we have this thing in our brains that goes, well, nature isn't this type of design, and therefore we look for those things that are differences. Does that seem accurate? I mean, is that why you, for example, Ron, didn't see the fractals as being purposeful when you first encountered them?
So I still, to this very day, I'll say, so this is African knowledge of fractal geometry, and I'm presenting to, mathematicians and physicists, and I can tell by their facial expression who in the room is just completely, a disbeliever, right? Just is not buying this. Mm-hmm. And it's so interesting when you look at the reactions of mathematicians to Benoit Mandelbrot, the father of fractal geometry. When he first started publishing this stuff, nobody bought it. And I can quote you professional journal articles that were saying this is complete garbage. There's no theorems and proofs. Mandelbrot is just running these computer simulations and telling us to look at pictures and saying, doesn't this look like something you'd see in nature? So you hear the same skepticism. People say, well, wait a minute, these Africans aren't doing theorems and proofs. They're just having us look at these pictures. Well, that's what mathematicians were doing, right? Mm-hmm. So there's definitely different sorts of bias coming in. Different kinds of lenses have been tuned in particular ways. And that bias will work out differently depending whether you're a mathematician or an architect or computer scientist, et cetera.
I would like to just add something about fractals. Please. I remember I didn't learn about fractals when I was in high school. The first time I learned about fractals was with Ron, getting kind of like a personal lecture on it. So I think that kind of math was missing from my educational experience.
Right. So some of your work that you published, Audrey, has to do with sort of some African roots in things that you see later on in graphic design in other Western traditions. And I wonder if you could describe some of those connections, and if they are a continuous evolution, are they co-evolution, what is the nature of those, or the relationship between these different instances as they exist?
Well, I'm going to start responding to that question by describing how it was for me working with Ron. I remember being in grad school and being exposed to the Lukasa. It came about through my own research. Saki Mafandikwa was my thesis advisor. And I think that it was really through him that I discovered the Lukasa, but I didn't know about the relationship that had with the research that Ron was doing. So when I arrived at RPI and kind of bumped into Ron getting off of the elevator in our building, we struck a conversation, and then he told me all about his work, and I told him about my thesis project in the Lukasa, and he went off on, the mathematical meaning that's kind of, or information that is embedded in that design. And as I continued this collaboration with Ron, I started to see connections. As a graphic designer, I was always attracted to the architectural kind of photos that he was showing me and imagining how they could be applied to the design of information, for page layouts and grids, etc. And when he started talking about the Fibonacci series, I remembered learning about that in typography with John Gamble at Yale School of Art. And I said, there is a connection here. And I went back to those books, but I didn't see any kind of reference to Africa, which was very, very odd to me. And I think that is what motivated my writing the article, the journal article that I wrote about that connection, that it may be that, Africa has contributed to graphic design history, but there's really no mention of it in the literature, the canon that I'm familiar with. I don't know if that addresses your question. I don't know, Ron, if you'd like to add anything, but.
No, it does. I mean, is it that the examples still persist in Africa and therefore are easy to see the connections, or potentially that those existed kind of everywhere? They were sort of sublimated and subsumed by other sort of advancements of extractive sort of use, and they did they exist simultaneously? Did they I just want a sort of sense of, like, as we're using this evolutionary metaphor, I want to know, like, is the evolutionary metaphor like a continuous thing? Is it a series of co-evolutionary things and convergences? Like, how are you seeing all that stuff?
Yeah. So what I find is that these indigenous cultures on different continents work quite differently. Yeah. And of course, even within one continent. But we also do a lot of work with Native American groups. And there you'll find this emphasis not on fractal scaling at all. In fact, the emphasis is on Cartesian grids, right? It's the four winds, it's the four directions, it's the four sacred colors of the Navajo, four sacred mountains. So against that grid, which is, created by humans, you're weaving or something like that, you're doing beadwork, you've got rows and columns, you have a grid. Against that grid, you have nature being highly unpredictable. And so it's viewing nature as this sort of stochastic force, right? The force of randomness against the kind of order that you're trying to put upon the world. So fractals aren't involved at all. It's a generative way of doing things. It's not extractive, but it's a very different kind of generative technology than what you see with recursion and fractals in Africa.
That's interesting. It seems like trying to put things on a two-dimensional grid makes the world even more chaotic. You know what I mean? Like, and therefore, then there's Absolutely. More ways to, like, if you view it that way, then there's more more ways that you have to cope with that kind of chaos.
There's a lovely Hopi story about first man and first woman, who the Christians would call Adam and Eve, placed the constellation we call the Big Dipper, the four stars, right, that give a fourfold symmetry to the sky. And then Coyote came along with a blanket full of mica dust, and that's why all so the sky would be orderly if you left it up to humans. It's just nature that's adding the disorder.
That's interesting. And so, given that that's the root of the thinking, like you mentioned that monotheism leads to monoculture, and the sort of like an embrace of the chaos leads to sort of an embrace of lots of different design solutions.
The need for diversity, yeah.
Exactly. Is there an equivalent towards the sort of fractal and generative design in the African examples that leads to, like, what is the continuation of that? Like, is there a more of a sense of algorithmically finding solutions to things, for example, or is there something that sort of continues on that thinking the way that you mentioned with the Native American?
Yeah. So both are forms of unpredictability. but one is based on a stochastic view, randomness, throwing dice, right? The other is a different form of unpredictability, which in mathematics we call chaos theory. And I'll give you an example of that. So a man walks into the woods and he sees this skull on the ground, and he says to himself, I wonder how you got here. And the skull looks up at him and says, talking brought me here. And he goes, oh my God, a talking skull. Runs back to the village and tells everybody about it. They all come out. He says, okay, go. And the skull just sits there. And the chief says, this man is tricking us, trying to draw us away from our protection of our fields. Off with his head. They chop off his head. Everybody leaves. And then the skull turns around and says, what brought you here? And the guy's head says, talking brought me here, right? So in the case of tricksters in Africa, unpredictability is the system folding back on itself. It's not stochastic. It's not throwing dice, right? It's that loop of a chaos system.
Oh, that is amazing. That is a great example. And Audrey, do you have, are there examples in the graphic design where you've seen that type of, that type of work that's been, really inspiring to you, or that you recognize that same sort of like, recursive sort of nature in the work?
I can't name one off the top of my head. I've been doing a lot of research on that to look for it in design. I remember in grad school, my peer, Michael Lawrence, who is African American, had designed a wonderful kind of book that had that kind of recursive design. That, embedded in its physical design, right? It was like a book inside a book inside a book. And at that time, I didn't really know anything about fractals and fractal geometry. But now, that was the one example that I thought reflected this kind of African history. Go ahead.
That image you showed in the slides of you interviewing Carol Harris, can you talk about that a little bit?
Carol Harris is a quilter local here in the area of Michigan, in Detroit. We became familiar with her work through an exhibition here at the Stamps Gallery that we saw. And I noticed, or Ron and I noticed, that her work reflected some of those recursive kinds of principles and concepts. And that's why we called and set up an interview with her to talk about the thinking behind her work. One thing that I was curious about when I started working with Ron was whether or not these algorithms were something that we were bringing and sort of attaching to the work, or whether or not those concepts are in the minds of the designers. And it's really important to understand that they are in the minds of the designers. So those designs are being replicated in Africa, right? As we sit here and speak, because it's in their minds. It's not something that we have brought and to describe this work.
Carol's connection to jazz, I thought, was really interesting when she was talking about the spontaneity of her quilts. And she listens to a lot of jazz, and of course it's jazz with Detroit roots, Roland Kirk and so on. And so the fact that she's composing those, from the bottom up, was a kind of recursive formation.
Well, this is fascinating stuff. And thank you so much for giving me like a little bit of a lens to like begin to view these things when I see them out in the world, when I see like art and the presentation of, all the cosmologies like that. It is like, it just made the world a whole lot richer for me, honestly. So I appreciate it. Thank you so much for joining us.